Section 28 of the Science, History of the Universe, Volume 1. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by K. Hand. The Science, History of the Universe, Volume 1, edited by Francis Rolt Wheeler. Astronomy. Chapter 20. Comets, Meteors, and Meteorites, Part 1. The term comet, derived from the Latin coma, or hair, applied to celestial bodies which appear to have a hairy appendage, goes back to the time of the Romans. A similar word, cometa, or cometes, was used by Cicero, Tibullus, and other ancient writers. The modern astronomer speaks of the coma of a comet as distinction from the tail, and applies the term to the misty, hazy light surrounding on every side a small central bright spot, which he calls the nucleus of the comet. While the ancients distinguished between comets and meteors, or shooting stars, yet they believed them to be of the same nature, and to be found in the Earth's atmosphere not far above the clouds, or at all events much lower than the Moon. The earlier and Pythagorean view, however, was much more correct, according to modern doctrine, for it held that comets were bodies with long periods of revolution, which idea, like others attributed to Pythagoras, probably came from the Eastern philosophers of unknown nationality. Apollonius, the Median, believed that the Chaldeans were responsible for this notion of the comets, for they spoke of them as travelers that penetrated far into the upper or most distant celestial space. Similar views, typical of the imitative faculty of the Romans, says Humboldt, were held by Seneca and Pliny. The Greek philosophers in many cases preferred to disregard observations. Hence the fanciful theories of Aristotle as regards comets, as well as other astronomical matters, were prevalent for many centuries. Aristotle even believed that the Milky Way was a vast comet which continually reproduced itself. The comet, with its brilliant head, flaming tail, and uncertain appearance, could not be regarded otherwise than as a divine omen to announce some remarkable event or to forebode evil, particularly pestilence and war. Indeed, for many years the death of monarchs was believed, especially by those to whom the wish was father of the deed, to be announced by these brilliant messengers in the sky. In some cases comets were associated with misfortunes, not merely as anticipating or announcing them, but as the actual causes. Seneca's statement that this comet was anxiously observed by everyone because of some great catastrophe which it produced as soon as it appeared, the submersion of Bura and Helice, referred to the very brilliant comet which appeared in 371 B.C., about the same time that these two towns of Achaia were swallowed up by the sea during an earthquake. A comet which appeared in 43 B.C. was generally believed to be the soul of Caesar on its way to heaven. Josephus informs us that the destruction of Jerusalem was announced by several prodigies in 69 A.D., among them a sword-shaped comet, which is said to have hovered over the city for the space of a year. Another classical instance may be quoted from Pliny, 23 to 79 A.D., in his Natural History, where he says: "A comet is ordinarily a very fearful star. It announces no small effusion of blood. We have seen an example of this during the civil commotion of Octavius." When the comet of 79 A.D. appeared, the Roman Emperor Vespasian refused to be intimidated by the frightening interpretation placed upon it. "This hairy star does not concern me," he is reported to have said. "It menaces rather the king of the Parthians, for he is hairy and I am bald." Not long after the appearance of the comet he died. No doubt the prophecies of the imperial soothsayer were more highly regarded thereafter. The ancient Greeks and Romans were not the only ones who took these heavenly apparitions seriously. In France, the great eclipse of 840 was said to have hastened the end of Louis le Debonair, and it was firmly believed that the comet which appeared a year or two previously presaged this occurrence. Much of the mysticism attaching to figures found expression in the superstition that the Christian era could not possibly run into 4 figures. Hence the end of the world was looked for by many of the inhabitants of Europe when the year 1000 approached. So widespread was this belief that husbandry and toil were neglected. When a comet appeared the feeling was strengthened. Nothing remarkable occurred, however, beyond the natural consequences of such wholesale neglect of the proper care of the soil. Famine and pestilence in succeeding years were the result. The comet, which we shall see, was the famous comet of Halley that blazed forth in April, 1066, was believed to presage the success of the Norman conquest, and the invasion of England by the Normans, guided by a comet, was a familiar topic for the chroniclers of the time. The abdication of Emperor Charles V was reported to have been influenced by the comet of 1556, but the event had already taken place before the comet made its appearance. Gian Galeazzo, the Visconti Duke of Milan, viewed the comet of 1402 as a celestial sign of his approaching death. A striking example of the manner in which the comet was regarded is contained in the contemporaneous description by Ambroise Paré, the father of French surgery (1517 1590), in which he speaks of the fear inspired by the comet of 1528. "This comet," said he, "was so horrible, so frightful, and it produced such great terror in the vulgar, that some died of fear and others fell sick. It appeared to be of excessive length, and was of the color of blood. At the summit of it was seen the figure of a bent arm, holding in its hand a great sword, as if about to strike. At the end of the point there were 3 stars. On both sides of the rays of this comet were seen a great number of axes, knives, blood-colored swords, among which were a great number of hideous human faces with beards and bristling hair." The comet of 1472, apparently, was the first comet to receive scientific study and not be regarded solely as a cause of superstitious terror. A series of observations were made in Franconia by Johann Müller of Königsberg, known as Regiomontanus. By the time of Tycho Brahe, while comets were not satisfactorily explained, yet they were being considered on a more rational basis, and the correctness of the Aristotelian doctrine was, as in other matters, being questioned. It was believed before this that comets were generated in the higher regions of the atmosphere. But in 1507, on the appearance of a brilliant comet, Tycho, in an elaborate series of observations, satisfied himself that the strange body was at least 3 times as far off as the Moon, and also that it was revolving around the Sun in a circular orbit at a distance greater than that of Venus. Comets subsequently were observed by Tycho and his pupils. His observations in this field led to those ideas of the solar system of his which we have discussed. It was but natural that Kepler, as a follower of Tycho, should have paid especial attention to comets. In 1607 he observed the comet now known as Halley's comet. Kepler believed that comets were celestial bodies which move in straight lines, and after having passed the Earth recede indefinitely into space. Assuming that these strangers in the heavens would never reappear, he did not consider that their paths required serious study, for which reason he made no observation to ascertain their movements and test his theory. Before Kepler, Jerome Fracastor (1483 1543) and Peter Apian (1495 1552) had observed that a comet's tail always points away from the Sun, no matter in what direction it may be traveling, and with this observation Kepler agreed, adding as an explanation the supposition that the tail was formed by rays of the Sun penetrating the body of the comet and carrying away with them some portion of its substance. This theory, after due allowance has been made for the change in our conception of the nature of light, is of interest as an anticipation of the modern theory of comets' tails. Kepler found himself compelled, in his treatise on comets (1619), in which the foregoing observations were published, to refer to the meaning of the appearance of a comet in its influence on human affairs. At this time there were striking events enough in the affairs of Europe to prove any theory of the influence of comets on human life. He realized, however, that comets are very numerous, for he states, "There are as many arguments to prove the motion of the Earth around the Sun as there are comets in the heavens." The motion of the comets was also studied by Galileo in 1623 as a part of the motion of the Earth in the Copernican theory of the solar system. But the first and most important contribution to the true explanation came from Dorfel of Saxony, who proved from the comet of 1681 that the orbits of comets are either very elongated ovals or parabolas, and that the Sun occupied a focus of the curve. Newton, discussing this subject in his Principia, reached independently the same conclusion a few years later, and established it as a universal law by incontrovertible mathematical proof. By the 17th century a considerable number of comets had been recorded. John Hevel of Danzig (1611 1687) published 2 large books on comets, Prodromus and Cometicus (1684), and Cometographia, 1668, which contained the first systematic account of all recorded comets. It was a brilliant thought of Newton's that led him to consider whether gravitation toward the Sun could not explain a comet's motion just as well as that of the planet, and if so, as he took pains to prove in the beginning of the Principia, such a body must move either along an ellipse or in one of two other allied curves, the parabola and hyperbola. Edmund Halley, 1656 to 1742, who had been a friend and active associate of Newton's and had assisted him for several years in the preparation of the Principia, followed Newton's principles in the observation of comets. He computed the paths of the comets of 1680 and 1682, and especially the one of 1531, whose appearance was recorded by Appian. His studies contributed much to the material dealing with this subject in the Principia, especially the later editions. In 1705 he published a synopsis of cometary astronomy, in which he calculated 24 cometary orbits. Discussing in detail a number of these, he was struck with the resemblance between the paths described by the comets of 1531, 1607, and 1682, and the approximate equality in the intervals between their respective appearances and that of a fourth comet observed in 1456. Moreover, there was historical record of a comet in 1380 as well as in 1305. He at once concluded that all four comets were really different appearances of the same comet, which moved around the Sun in an elongated ellipse in a period of about 75 or 76 years, and he accounted for the small differences in the different intervals between the appearances of the comet by perturbations caused by planets in whose neighborhood the comet passed. He then made the first prediction of the probable reappearance of the comet, assigning the date 1758, when it would next be seen after a 76-year interval. Halley, no less than modern astronomers, was aware of the disturbance that the presence of the planets might work in a comet and its orbit, and how its time might be altered. He confidently announced the actual appearance of the comet, but left shortly before his death at the age of 85 years the following quaintly worded statement in regard to the comet: "Wherefore, if according to what we have already said it should return again about the year 1758, candid posterity will not refuse to acknowledge that this was first discovered by an Englishman." When the time arrived the comet was looked for by astronomers, the French savant Alexis Claude Clairaut (1713 1765) computed the various perturbations which might have affected its journey. As its path lay through the orbits of Jupiter and Saturn, and as it passed close to both of these great planets, his calculations showed that there might be expected a retardation of 100 days on Saturn's account and 518 days for Jupiter. On Christmas Day, 1758, a month and a day before the date assigned by Clairaut, and in the year announced a half century before by Halley, the comet was actually discovered by George Pallich, 1723 1788, of Saxony, and the great astronomical prophecy was thus fulfilled. A new member was added to the solar system; the wandering and fear-inspiring comet was thus brought into harmony with the other members and made subject to the fundamental calculations of the astronomer. Whatever superstition had attached to these wonderful apparitions had now all but passed, and comets were found to present problems no less interesting than other celestial bodies when their fundamental motions were known. In 1835 Halley's comet duly reappeared and passed through its perihelion within a few days of the time set for it by astronomers. It was observed, among others, by Sir John Herschel at the Cape of Good Hope. In 1910 this comet returns again along the orbit shown in Fig. 30. It was first discovered by Wolf of Heidelberg on September 11, 1909. In the study of Halley's comet in connection with its appearance, much attention has been devoted by astronomers to its earlier history, particularly that recorded in Chinese and European annals. Messrs. Cowell and Crommelin at the Greenwich Observatory have carefully examined the previous work of Hind and have found it in the main correct. Halley's comet unquestionably must be identified with one that occurred in 1066, the year of the Norman conquest, a representation of which is now extant in the Bayeux tapestry, supposed to have been worked by Queen Matilda and her ladies. In the more modern times comets have been associated with some important development of scientific theory rather than with historical events. The comet of 1811, visible from March 26th of that year until August 17th of the following year, received the attention of Sir William Herschel, who discovered that it shone partly by its own light, which developed as it approached the Sun. This comet had a tail at one time 100 million miles in length and 15 million miles in diameter. Dr. Olbers suggested that electrical repulsion was responsible for the formation of the tail. A comet famous for the fact that it was the first of the family of Jupiter's comets to be discovered was that named for Johann Franz Encke, for many years the director of the Berlin Observatory. It was discovered by Pons of Marseilles, November 26, 1818, but in the calculation of its orbit and other elements, Encke found that it revolved about the Sun in a period of 3 1/3 years, which is considerably shorter than that of any other known comet. Furthermore, he established its identity with comets seen by Mechain in 1786, by Caroline Herschel in 1795, and by Pons, Huth, and Bouvard in 1805. Encke's calculations, after establishing its periodicity, assigned the date of May 24, 1822, for its next return to perihelion; and though on account of the position of the Earth at that time it was invisible in the northern hemisphere, it was detected at Sir Thomas Brisbane's observatory at Paramatta by Rümker very nearly in the position indicated by Encke. This was only the second instance of the recognized return of a comet, so that Encke's work as an astronomical achievement should be considered with that of Halley. Section 28.